If velocity is constant, then speed must be constant. I'll give another example where it will change the direction. Here, it will continuously will move in same direction, particle 1. If velocity is constant, then speed would be constant. Yes, it must be, no, there's a correct statement. But if speed is constant, then velocity may not be constant, direction may change. As if you see this, it is moving with a speed v2. If velocity constant, speed must be constant. If speed is constant, velocity need not be constant because there can be change in direction. I think the justified. I just give an example with the help of these things. So for this statement, there's a diagram. For this statement, there's a diagram. If a particle is moving with constant velocity, then for any time interval, average speed is equal to magnitude of average velocity equal to speed equal to magnitude of velocity. I think that this again will take help of the graph. Then you go for the slope. If particle is moving with a constant velocity, so I think if a particle moves with a constant velocity, this is a position versus time graph. This is a delta t. This is a delta s. So what is V average? Delta s by delta t. This is also equal to V in, no? Since it is moving along a straight line, so no change in direction of motion. Then for such a motion, the magnitude of average velocity or average speed, magnitude of velocity or the speed, everything will be same. If a particle moves with a constant velocity, then for any time interval, either again you pick up time interval here or here, anywhere, any time interval, this will be a valid one. A particle is moving in a straight line without changing its direction of motion, then speed equal to magnitude velocity. Average speed or an interval should be equal to magnitude of average. I think the same thing just now. Average speed or an interval should be equal to magnitude of average velocity. Both are same, no? Instant speed and average speed may differ. I think for a particle moving a straight line without changing its direction of motion, then instant speed and average speed, no, it will be same. Compared to that statement, no, a particle is moving along a straight line. I'll push it here. Okay, look at the this statement: the particle moving straight without changing the direction of motion, then instant speed and average speed may differ. Not wrong statement, no? It's a wrong statement. Huh? The velocity of particle is constant, then average velocity for different intervals would be same or different. Will be same. You can take any interval of time. Everything through graph, better to interpret, so that will be easy for us. Now, if I take this, for different intervals would be same. Different intervals is telling. So the intervals of time, I'll change it. Let's see what we'll get it. Look at the intervals of time. I change it correspondingly. This is delta T1, delta T2, delta S1, delta S2. This is the position. This is the time. What you can say about the slope? Okay, I'll just shade that triangle. Please look at the triangles, which I'm going to shade it. What is the slope of these two triangles? Will be seen. Tan theta 1 is equal to delta S1 by T1. Delta S1 not equal to delta S2. Delta T1 not equal to delta, but still the average speed will be same. And this should be equal to what? The average speed, or it is also equal to instantaneous speed. In uniform velocity motion for different intervals, even then the intervals of time you take it, then definitely the corresponding displacements will be different, but the ratio of displacement time taken will be same. I think this will be same or different. So what we should say, same. I'll strike it out. We'll